This is a continuation from our last lecture. So our last video, or our last class if you're in 5th period, we talked about what composite functions were and how they worked. So now we're going to actually work through a few examples of those. So the first one, we have f of x is 3x plus 2, we have gx is 2x minus 1, and h of x is x plus 1. These are our three functions that we're going to use. So number one says, what is f of g of 3? So f of g of 3, so we're going to do f of x, but instead of f of x, we're putting g of 3 in there, right? So we're going to start with our g of 3. So you always start from the inside. So our inside one is g of 3, so that we're going to take our function, which is 2 times x minus 1. Well, we're plugging in a 3, so this 3 goes there in place of the x. So now we have 2 times 3 is 6. So this is 6 minus 1, so that's just 5, right? That's g of 3. That's our output. But now we're not done because that's g of 3, but we still have this f going on. So we've got this f of that. So now we're going to take it to our next level out. And we're going to say we're going to do f of x, but instead of an x, we're plugging in our output from the last one. So our output was 5, so that's going here. So we put our 5 in. So now our f function says 3x plus 2, so this is 3 times our x value plus 2, but our x value is now 5, so we put that there. So that's 3 times 5 plus 2. Well, 3 times 5 is 15, so that's 15 plus 2, so that equals 17, and that's our final answer. So f of g of 3 is 17. Now notice that's not f of 3, that's f of g of 3. If we plugged in an f of 3, we wouldn't get the same answer. So let's just prove this to ourselves. So f of 3, again we have our 3x plus 2. So if we plug a 3 in, our 3 goes here. So that's 3 times 3 is 9, plus 2 is 11. That's not the same thing as 17. So this and this are not the same. So when we're plugging in f of g of 3, we're not doing f of 3. We're doing f of whatever came out of g of 3. So we're doing it in steps. Okay, let's try this again with our second one. I'm going to copy and paste this over so that we have everything. So copy, paste, my favorite thing in the world. Done. Good. Okay, so now we have our f of g of h of 1. So this just got uglier. We have f of g of h of 1. Again, we're going to start from the one in the very, very beginning, or in the very middle. So we're going to do h of 1 first. Ooh, let me make that purple, then it'll match. Okay, we're going to do h of 1. So we have our h function, right? H of x is x plus 1. So if we plug that in, so we get h of 1 equals x plus 1. Well, our x in this case is a 1. So this is just 1 plus 1, which is 2. That's our first output. That's h of 1. So now we need to take it to the next level out, which is our g value, right? So we're taking it down our little stair steps. So now we're going to do g, but we're doing g of 2 because that was what we got from the first step. So this goes in here. So now for g of 2, so g of x is 2x minus 1, so this is 2 times x minus 1. But our x value in this case is a 2. That's what we're plugging in. So 2 times 2 is just 4. Now we have minus 1, so 4 minus 1 is 3. That's our second output. Da-da-da! Now, so we're good with the g, so now we got to go to our f value. So now we're stair-stepping it, we're going to this one. So we're going to go f of, but we're not doing 1, we're doing f of whatever we got before. So our last step we got a 3. So we're going to take this 3 and we're going to plug it in here. Ta-da! So now that is going to get plugged into our f function. Well, f is 3 times x plus 2, but our x is a 3. So now we get 3 times 3 is 9, plus 2 is 11. And we're out of stair steps. That's the last one. So that means that is our final answer. So f of g of h of 1 is just 11. Okay, let's do one more. Let's do a funky one. Let me copy and paste again. Okay, copy. Okay, I accidentally grabbed these with it. Okay, let's do something funky. Let's do f of g of 1. Or no, let's do h of f of 2. So we're leaving off the g for this time. It doesn't matter. We just have them defined up there in case we want to use them. Okay, so in this case, our inside function is our f, right? F of 2. So that's what we're going to start with. So we start with f of 2. So our f function is 3x plus 2 from up here. Still using the same functions. So we have 3x plus 2. Only we're plugging in a 2 for our x, right? So we have 3 times 2 is 6. Plus 2 would be 8. Okay, that's our first output. Yay! Hooray, output. Now we got to plug it in again. But now we're going to go one step out. So we're going to go to this other f. So we're going f. Only we're plugging in 8 this time because that's what we got. So this one came way over here and got put in there. Okay, so now we're using our same function. We have 3 times x plus 2. Only our x now is an 8. Okay, 3 times 8 is 24. Plus 2, that gives us 26. Okay, so we have an output. Yay! Now we go to our next stair step. This is super exciting. So now we're going to the h. So our h of x is x plus 1, only instead of x, we're plugging in our 26. So 26, because that's what our output was. So every time you get an output, it's just going to go in as your input on the next line. So I have h of 26 equals x plus 1, well your x is 26, plus 1, that equals 27. Now we're done. That's our final answer. We don't have any more levels. So that's just composite functions. We're just taking the output from the inside, we're putting it into the next outer one, and then we take that output, we put it into the next one, and the next output into the next one, and we just keep going until we run out of functions.